This is Algebra 1, Lesson 17C, the distributive property. In a previous video, we talked about properties, and I gave the example of gravity being a property and how even when you are very small, you will drop something to watch it hit the floor. You understand that gravity is a thing even if you don't know what to call that thing. And so we are used to properties, the way things behave in this world. Well, in mathematics, there are lots of properties. You've already learned, and you already knew this, you may not have had a name for it, that if you add 2 and 5, you get 7. And you're not shocked that when you add 5 and 2, you also get 7. You can change the order of the numbers that you add, and you will get the same answer. That property is called the commutative property of addition. There's also a commutative property of multiplication, and we talked about the commutative property before. Today we're going to talk about a different property, and that's the distributive property. Now when you look at this word, it's got the word distribute in it, and it gives me the idea. I always kind of think of a paper person. You know, when people used to have papers and they would ride their bike around and they would go to each house. Here's each house, and all of the people in this neighborhood have paid for a subscription. He's got maybe his bag over here, and he's pulling out papers, and he throws one to this neighbor, and he throws one to this neighbor, and he throws one to this neighbor. He is distributing the newspaper to each house, okay? Kind of an old idea, I guess, right? Well, he needs to make sure he sends one to every house who's a subscriber, right? It's important that you take it to every subscriber. Well, that idea can be used to remember the distributive property in math. Now, I'm going to use that property in just a second. First, I'm going to work this problem the way you already know how to work it, okay? Over here on the left. Let's do it the way we already know. We would look at this and we would say we have symbols of inclusion, so we can start there. 5 minus 3 is 2. Let's copy everything else down. Now I can do that multiplication, and 4 times 2 is 8. Not hard, right? You know how to do that. There's another way to do it, and it's just the way numbers work. This works, okay? And that is by doing the multiplication first. Now wait, I know I've told you you need to do what's in the parentheses first, but this is an example where it actually works to do the multiplication first. You just have to be like the paper guy here and make sure you distribute to every term. We just learned about terms. Terms are separated by addition and subtraction. So we're going to make sure we multiply by the 4 to both of these terms. That's going to look like this. 4 times 5 and then minus 4 times 3. Now watch and let's see what we get here. Let's do the multiplications. We get 20 minus 12. We go ahead and do that, and we end up with 8. We get the same answer. Now, this does not mean that order of operations are not valid. They're still valid, right? This is just the way numbers behave, and it works when you are multiplying across addition. Now, I know you may say, wait a second, this is not addition, this is subtraction. But remember, we call that algebraic addition because it's like adding the opposite, right? You're going to get the same answer. So this book calls it algebraic addition. The distributive property's technical name would be the distributive property of multiplication over addition. Now, you can't do multiplication over, addition over multiplication. Okay, our number system doesn't work that way, okay? But it does work for multiplication over addition, and since you can rewrite a subtraction as an addition, it works for subtraction as well. So like they do with properties, let's look at this in general terms. The distributive property is for any real numbers, A, B, and C, okay, so these are our numbers. If you have A multiplied by the sum of B and C here, it's going to be the same as if you multiply the B and C both by the A and then add them together. So it's really that last example, we just wrote it in general terms with an A, B, and C. It's important to be able to read these and understand that they're just representing numbers with variables, and it could stand for any numbers, any real numbers, okay? Now, they take it a little further and they say there's an extension of the distributive property. For any real numbers, A, B, C, D, and look, keeps on going here, okay? You can keep going forever, all through the alphabet and beyond. Then they give you this example, A times, and in parentheses, B plus C plus D plus, here again the ellipses saying it keeps on going, that as long as you keep on going, you just multiply that A by everything. That newspaper guy is throwing a paper to everybody on the route. Everybody, as far as it goes, okay? The most common error I see when students do the distributive property is they will distribute to the first term and then not to the rest of the terms. But you have to distribute the number on the outside to every term on the inside of the parentheses.